everyone, we're going to find the intervals of increase or decrease, find the local max and min values, find the intervals of concavity and inflection points, and sketch the graph. And this is our function c of x. So to find the intervals of increase and decrease, we're going to take the derivative of this and then determine if our derivative is positive on the interval, then f is increasing. If our derivative is negative, then it's decreasing on the interval. First thing I'm going to do is just distribute that. So if I have x times 1/3 times x to the 3/3, because that would equal 1, that's x to the 4/3. So I'm going to rewrite this as c of x equals x to the 4/3 plus 4x to the 1/3. And then I'm going to take the derivative. So c prime of x equals 4/3 x to the 1/3 plus 4/3 x to the negative 2/3. Now to set this to 0, I'm going to factor out 4/3 because this is common, and you pick your smallest exponent, x to the negative 2/3. And that's going to give us x plus 1. And that makes it easier to determine where it's positive or negative. I can rewrite this as 4x plus 1, and 3 goes in the denominator, and this would be the cube root of x squared. All right. Now, looking at it, we know that our critical values, if you set this to 0, is where it's undefined. So that's x equals 0. It's undefined. It is defined here, but not with the first derivative. And also, x is negative 1. So to find increasing and decreasing intervals, I'm just going to set up a sine graph from negative 1 to 0. So if I plug in, say, negative 2 here into my derivative, I'm going to get negative 2, and that's going to be negative. And if I plug in negative 2 here, it's going to be positive. So we have a negative and a positive, gives me a negative. If I plug in negative 1/2, I'm going to get positive divided by positive, so that's positive. If I plug in 1, I'm also going to get positive. So basically, this is increasing, or it's decreasing on negative infinity to negative 1. So that's decreasing interval, and it's increasing on negative 1 to infinity. So basically what's happening is it's decreasing to 1, then it's increasing past 0, like that. So we have a local minimum at negative 1. And you plug in negative 1, you get fc of negative 1 equals negative 1 to the 1/3, which is negative 1, and negative 1 plus 4 is 3, so that's going to be negative 3. So your local minimum happens at negative 1, comma, negative 3. That would be this point here on the graph. So we did part A and B, and now we have to do the concavity test by taking the second derivative. So I'm going to use this here to start to go by my second derivative. So I'm going to copy that down. So our first derivative was f prime of c is c of x is 4/3 x to the 1/3 plus 4/3 x to the negative 2/3. Now let's do our second derivative, and that's going to give us 4/9 x to the negative 2/3 minus 8/9 x to negative 5/3. All right, and let's factor this out. I'm going to pull out the 4/9, and you pull out your smallest exponent. Negative 5/3 is smaller than negative 2/3. So you're going to pull out 4/9 x to negative 5/3, and that's going to give you x minus 2. And for concavity, we're going to check if it's positive and negative. So we're checking again at 0 and 2. And just take both of these pieces. We're going to check for that. If I plug in negative 1, I'm going to get negative times a negative is positive. If I plug in 1, I'm going to get positive times a negative is a negative. And if I plug in 3, I'm going to get a negative times a positive. If I plug in 3, I'm going to get positive and positive. So that's positive. All this means this is concave up, concave down, and then concave up. So basically that means concave up is from negative infinity to 0 and 2 to infinity. Concave down is the interval is 0 to 2. So basically what we want to do is check our inflection points by plugging it in. If I plug in 0 here, I get 0, 0. So that's an inflection point. If I plug in 2, I'm going to get 2 to the 1/3 times 2 plus 4. So that's going to be 6 cube root of 4. So at 2, we have 6 cube root of 4. So these are our inflection points. Cover that up. And then you do the graph. And here's an inflection point here. So basically we had decreasing, increasing from here. And then our inflection points were at 0, 0. So that was concave up and concave down. And for this one, it was concave down to concave up. I'm exaggerating it a little bit so you can kind of see what's going on. So our inflection points are here and here. And you had a local minimum at -1, 3. -3. So that was -3 there. And that's it. Thank you. Have a nice day. Bye-bye.